Let's simplify some fractions. This is a complex fraction. I have a fraction within a fraction. If you notice, all of this stuff up here is the numerator of the big fraction. And this little guy down here is the denominator of the big fraction. Okay, so we're going to clean this up. We want one clear-cut fraction, one numerator and one denominator. So there are two ways to do this. One way is to find a common denominator of the numerators. So we can find a common denominator of the fractions in the numerator. So to do that, we look at their denominators. Their denominators are x and y. We want the least common multiple of those. That's going to be x times y because they have no factors in common. So we can build a common denominator if we want to. If we build a common denominator, we're going to rewrite this fraction bar right here. I'm rewriting it as a fun word. Again, that's called the vinculum, if you've heard me say that before. And we're going to rewrite 7 over x. And I'm going to multiply by a fancy number 1. Okay, I'm going to pick a number 1. All I mean by a number 1 is the same thing in the numerator as in the denominator. So I would like this least common multiple, this x times y, to be my denominator. So the piece that's missing, the term that's missing in my product is a y. If I multiply the denominator by y, I better multiply the numerator by y. That way I'm multiplying by the number 1. And then I'm going to do the same thing with the next piece. This is negative 5 over y. I need the least common multiple again to be x times y. So this piece is multiplied by x because we have a property called the commutative property that says a times b is the same as b times a. So we know x times y is the same as y times x. So I'm going to go ahead and just put it over here. If I multiply the denominator by x, I have to multiply the numerator by x. I could have actually done it on this side as well, but I went ahead and did it the same way I did the first one. Okay, and for now I'm just going to rewrite that denominator of the entire fraction. Okay, so I'm going to rewrite the vinculum in the denominator again. In the numerator, you have x times y as this denominator, and y times x is this denominator. We said those are the same thing. So this is 7y over xy minus 5x over xy. Okay, and you notice these have a common denominator now. So we know that if you have a over b minus c over b, you rewrite the common denominator and you combine the numerators like this. So that's what we're going to do. We're going to rewrite the common denominator, xy, one time, and we're going to combine the numerators, 7y minus 5x. And this 3 over x is still in the denominator. Now, we know that if we have a fraction and we're dividing it by a fraction, we do two things. Number 1, we rewrite the fraction in the numerator. Okay, I'm talking about this guy right here. So we rewrite that, 7y minus 5x over xy. So I'm rewriting that. The second step is then you multiply that by the reciprocal of the fraction in the denominator. When I say denominator, I'm talking about the entire big fraction. So I'm looking here, and this guy is the one I'm going to use the reciprocal of. So I'm going to multiply by x over 3. I'm going to flip it, right? Flip the numerator and denominator. That's how you get the reciprocal. When you do this, you're going to see we're going to be able to cancel this x. This x will cancel with that x because it's a product. So then your final answer is 7y minus 5x over 3y. And you may be wondering why I did that. But if I have a over b times c over d, I multiply the numerators and multiply the denominators. I get ac over bd. Let's try another one. Simplify 2 plus the fraction 1 over m minus 3, and we're dividing that whole thing by 5 over m minus 3. We can use the same process. We can build a common denominator in that numerator. So again, look, there's a numerator right here that has a fraction in it, and here is the denominator. It may be helpful to rewrite this as 2 over 1 plus 1 over m minus 3 as my numerator, and then 5 over m minus 3 as the denominator. Find the least common multiple of the denominators of the fractions in the numerator. The reason we're doing that is we are going to find a common denominator. That's going to be our common denominator. So the denominators are 1 and m minus 3. Well, 1's not very exciting. The least common multiple of those is m minus 3. So we're going to build a common denominator. Draw my big vinculum again and rewrite the fraction that's in that denominator. Now I'm going to multiply by a fancy number 1. That just means the same thing over itself. How do I choose? Well, I would like these denominators to match, right? I need a common denominator, and I need them both to be the same as the least common multiple that I found. Okay, so I need an m minus 3 in this denominator, but that means I better also put it in the numerator. And if you look at this other fraction, it's good to go. It has the piece I need in the denominator. Okay, so as we said earlier, if you have a fraction times a fraction, you just multiply the numerators and multiply the denominators. So this is 2 times m minus 3 over m minus 3 plus 1 over m minus 3, and the whole thing is divided by 5 over m minus 3. As we said a few minutes ago, a over b plus c over b, if they have a common denominator, is the same thing as a plus c over b. Rewrite the common denominator and combine the numerators. So this is m minus 3, that is the denominator that's in common with both, and then 2 times m minus 3 plus 1. The whole thing is divided by 5 over m minus 3. Here's my numerator, here's my denominator. The numerator can combine. I can think about distributing here. Those are arrows. So we end up with 2m minus 6 plus 1. All of that is over this guy. So this is my numerator, this is my denominator. So I have 2m minus 5 over m minus 3. I'm dividing by 5 over m minus 3. You see again, we have a fraction divided by a fraction. So we're going to rewrite the numerator, and we're going to multiply by the reciprocal of the denominator, which just means flip it. 5 is in the numerator, it goes in the denominator. And m minus 3 was in the denominator, now it's the numerator. Okay, the reason we're doing this is to clean things up. We want one nice fraction instead of a fraction divided by a fraction. We see some cancellation. M minus 3 is in the numerator and in the denominator. We end up with 2m minus 5 over 5. That's your final answer.